Hi everyone, I hope you're okay and I hope that the videos will keep uploading and helping you out. This is the sixth video guys whereby I'm focusing on question 6 from the May-June 2024 Mathematics Paper 2 exam. And please note that guys, all the other questions rather, are already uploaded and each and every question have their own video. And please do share the video to your peers guys, because I believe that if you know how to tackle exam-like questions, it will give you an edge whenever you write your exam. So just stay tuned guys and wait for more videos. Okay, in the diagram, the graphs of f and g are drawn for the interval where x is between negative 180 and 180. The graphs intersect at n, p, and q, and then we are told that p is also the turning point of both graphs. Okay. Firstly, they want us to find the period of f. Period, guys, is always 360 all over the coefficient of x. That's one. So our period is basically 360 degrees. So our period is 360 degrees. Né? The amplitude of graph G, the amplitude is just the coefficient over there. So our amplitude is basically equal to 1. And then the value of A. The normal graph, guys, for course, it has a local maximum at the y-axis, but now my graph has a local maximum over there when x is equal to 45 degrees. I know that at the y-axis x is equal to 0, and now it simply means that my graph has been shifted 45 degrees towards the right. And if my graph is shifted 45 degrees towards the right, it simply means that the equation for f of x is basically equals to cos x minus 45. Are you together? That simply means the value of A is negative 45. Then now they want us to calculate the value of K, which is the y-coordinates of N and Q, okay? And without the use of a calculator. They want us to find the value of K without the use of a calculator. We can either use point N or point Q. Are you together? And these 2 points, guys, they exist in both F and G, right? So we can simply use the graph of G. I know that sine of 2x is equal to g of x, né? Let me write properly there, is equal to g of x. But now I just need to substitute these values. Né? I know that y is k when sine is 165 degrees. Whenever I use point Q. Né? So 165 multiplied by 2, this will simply give me 330 degrees. 330 is in the fourth quadrant, and in the fourth quadrant sine is negative. Okay, but before we do that, let's just reduce this angle. Né? 330 is in the fourth quadrant. In the fourth quadrant, we express angles as 360 minus. So therefore K is basically negative sine 30 degrees. Né? And that's negative 1 over 2. Hi. Okay, that's negative 1 over 2. Where the hell is this? Negative 1 over 2 over there. Né? And then now we are being asked to calculate the value of x if both of my graphs are shifted 60 units to the left. Are you together? Whenever we shift both of these graphs 60 units to the left, every x value will be shifted 60 units to the left. Every x-intercept, every x value at turning point, every point of intersection will be shifted 60 units to the left. Né? Such that the image of P will simply be negative 15 and 1. The image of N will simply be negative 135 and k, that's negative half. And then over here we still have the same thing. Q is shifted 60 units to the left, so the image of Q will simply be 105 and negative half. It's good. So but they want us to find just one root, which is just between that restriction over there. So this is the only point which is between that restriction. So x is only equal to negative 15 degrees. And then now we are being told that without using a calculator, determine the number of solutions the equation has in the interval of negative 90 and positive 90. Clearly show all the workings. Okay, I still have, why do I say I still have? Okay, I just have root 2 multiplied by sine x all over sine x plus cos x. Né? Since, guys, I'm not supposed to use a calculator, that means I'm not supposed to determine the general solution. Are we together? I just need to use whatever that I have. I do have the graph of sine x, but and I also have the graph of f, which is cos x minus 45. So I must try to make this look like cos x minus 45. Before I do that, I just need to change the order over there. That's 2 sine x is equal to cos x plus sine x. By changing the order, guys, there are no changes in this equation because addition is commutative. 1 plus 2 is basically equal to 2 plus 1. The order you decide to place them in, it doesn't matter. Okay, I can simply divide both sides by the square root of 2. I'll end up having sine 2x being equal to 1 over root 2 multiplied by cos x plus 1 over root 2 multiplied by sine x. Né? So I still have sine 2x is equal to cos x multiplied by cos 45. 1 over root 2 is also equal to cos 45. Né? And 1 over root 2 is also equal to sine 45. So I can see that I have an expression of a compound angle on my right hand side. I'll simply have cos x minus 45 degrees. So this is g of x being equal to f of x. And I do have the points of intersection, né? But I'm only allowed to consider the ones which are just between negative 90 and 90. So negative 90 and 90 is just in this region over there. So I must just consider these 2 points of intersections. So I simply have 2 points of intersections over there, guys, between on the given restrictions. Are you together? I simply have 2 solutions on the given restrictions. That's how, guys, we're supposed to tackle that question over there. Just stay tuned and wait for more videos. Thank you.